Okay, so let's do the classic boat across the river problem. Here's an example of a boat across a river problem. A boat traveling east at 8 meters per second is trying to get across a river that's 80 meters wide. That is, and the river is traveling south at 5 meters per second. The three questions that we will always ask you is, number one, what is the resultant velocity of the boat? Number two, how long will it take to cross the river? And number three, how far downstream will the boat go? Now, you should already have in your notes the big notes for how to do these problems. There's three very important things that you must include. Number one, you have to draw a picture which includes the correct direction of the river and then everything also inside the river. After you've made your picture, then you have to draw a coordinate plane placing the vectors correctly on that. So let's go through the directions for that on the board. As you can see, I already drew the river, and since the river is flowing south at 5 meters per second, I drew a river that looks like it's going to flow south. If it said the river was flowing east or west, I would draw the river the opposite way. So let's put everything inside our drawing first. That's step one. So we've got a river flowing south, and it's flowing at 5 meters per second. It says that the boat is going to be heading east at 8 meters per second. So I typically just draw a box representing a boat, and here's the 8 meters per second. The only other thing we're going to add to our drawing is the width of the river, or how far across the stream it actually is. And in this particular problem, it's 80 meters is the width across the river. That's step one, placing all the information we have into the river. Now, that's very similar to last chapter when we were doing free body diagrams, where once the drawing was made, everything seems to fall in place. The same should be true with boat across the river problems. Step two, we need to take these vectors and place them correctly on a coordinate plane. So we're going to do that next year. I'm going to take the 8 meters per second due east, put that on our plane here. We got 5 meters per second due south, which would be right here. And again, the correctly add vectors, we would not just connect head to head here. We have to pick one up and move it. And I'm going to pick the 5 up and move it over here so that the tail of the 5 is next to the head of the 8. And the way we draw our resultant, as always, is we start at the origin and we draw a new vector, which we call R for resultant, to the head of the last one drawn. So now we have a nice little right triangle here that we can work with. And of course, to find the resultants, we're just going to take, we're going to take 5 squared plus 8 squared square root. And when we do that, we find out that the resultant is going to be equal to 9.4 meters per second. And then that second part is always the at, or in other words, the direction. So we got to work on that next. So what we're going to do is we're going to find this theta right here. Again, we always want to find a theta that's touching the origin. So in order to find that theta, we have a nice little triangle here. We're going to use tangent theta equals opposite 5 over 8. And in this case, theta ends up being equal to 32 degrees. Now 32 degrees is not our answer because 32 degrees is in quadrant 1. And we're clearly in quadrant 4. So this is just the angle inside that triangle. What we want is the direction measured from east going all the way counterclockwise to that vector right there. So the way I always do that is it looks like to go all the way around is 360, and we're 32 degrees short of going all the way around. So 32 from 360 minus 32 would give us 328 degrees. And 328 degrees is our theta that we need for the rest of the result. That's the answer to the first question. What is the resultant velocity? Now the next two questions is how much time does it take to cross the river? So in order to figure out how much time it takes to cross the river, according to the notes that I give you, you always want to use the vector pointed in the direction of the question. In this case, if we're talking about across the river, we're going to use the vector pointed across the river. So what do we know? We know v across the river is 8 meters per second. We know d across the river is 80 meters. What we don't know is t. And of course, v equals d over t. So solving for t, we get t equals d over v. Or in other words, t is equal to, let's see here, d is 80 divided by v, which is 8. So t equals 10 seconds. That's the answer to our second problem. That's how much time it takes to cross the river. The third question is, how far downstream will this boat end up? Now, in order to do this problem, again, we're going to choose the vector pointed in the direction of the question. So if we're talking about downstream, we're going to use the downstream vector. So to figure out how far downstream we are, we need to use our v equals d over t formula again, except this time the v is the velocity of the river. So v is equal to 5 meters per second. The d we don't know, and the t is equal to 10 seconds, which we just found. So in order to find d, all we got to do is take v times t, which is of course 5 times 10. So our answer for question number 3 ends up being 50 meters downstream, and we square it in, and we're done with the problem. That's how to do boat across the river problems, going through all the steps. The important thing I want you to note is that our drawing is separate from our coordinate plane. Please do not put your coordinate plane in the drawing with the river.